How do you determine if a speaker is capable of covering a given audience area? In this video, audio engineer and system designer Michael Curtis will be showing us how to choose and position speakers for optimal coverage. Oh, and be sure to download his free audio math survival spreadsheet using the link in the show notes below this video.
So we've all been on a show like this. It's just an outdoor pavilion. We got a couple of speakers on sticks, and we need to ask ourselves, is this enough? Can everyone in the audience hear clearly? And so we want to make sure that no matter we got, this random dude over here who's not standing in front of our speaker versus this person in the front row versus this person who has a speaker point over here, are they pointing the right direction? Are they in the right spot? Do we even know that these speakers can actually make sure that everyone can be covered by the speakers? So is that up to the power rating of the speaker, the SPL that you want, how big the audience is, where the stage is, the coverage pattern of the speaker? As you can see, there's a whole lot of factors that influence how we pick a speaker and where we put it. And that's what I want to walk through today. How can we solve this Rubik's Cube of the show that we're on and make sure we set ourselves up for success? Speaker selection and coverage 101. We'll go through that today. So my sound system design philosophy stems from 5 steps. They're not necessarily sequential, but they're all really interrelated. And today we're going to be focusing on the right speakers in the right place with the right aim and coverage. And then maybe later on we could cover right level and right tone once we get down to system tuning. It's tempting to think of this as a domino method. I just push one, then the other, and then the other. But if I have a giant show that I'm on with a very big audience, it's not a one-size-fits-all with any speakers. So we have to use that information to determine what speakers we're going to bring with us or decide if it's going to be a good fit. So what we're going to learn today is what factors influence what speakers we choose and why. And so if we're on this stage, can we get good data from what we're doing on this show and make accurate decisions? Then also, how do I make sure my entire audience area has enough or adequate coverage? So you may ask, what is speaker coverage? You can think of it like a flashlight. If we had this laid down on the table, its lens is only letting light out the end and at a specific angle. So just like we have speakers, we want to point them at people, not the walls, not the ceiling, not back at the stage. We want to point them at our audience. It's just the exact same as a flashlight. Anything you want to see, you point a flashlight at. So today, I want us to borrow a few tricks from the lighting department and bring them over to audio world. So we can see up here at the top, we've got this grid of lights and they're all spaced in a manner so that when they're all pointed down at the stage, they're covering. So we have discrete elements right here, all right in a row that really don't make sense. But when you see what they're pointing at, we have a nice, fairly even sage wash down here at the bottom. So the same thing with their sound system. How can we make sure in transition, make sure we don't end up with something like this? So this is now a bird's eye view of a system design software called Map 3D. And these are 2 really narrow speakers. And this is the same audience that I showed you a little bit earlier. It's almost a square shape, but we can see here that the red means I have high level, and then yellow means like medium level, and then blue starts to taper off. And then we can see here in the middle in the black, that's where the level starts to get really drop off a whole lot, which means low intelligibility. It's not very loud right there. So these 2 speakers, even though they're placed evenly and they're right next to my stage, are not doing a good job of covering my audience. They're really narrow versus having a speakers that is perfectly fitted to match up with this audience size is what we're going for. So we can see here, there's a huge disparity in this weather map, if you will. The goal in this specific case, it's not to have a rainbow. We want it to be the same color throughout or close to it. We can see here on the top right, the legend has the red is the 0 dB mark, and then orange is our -6, then yellow is about -7. So I can see here with this audience shape, the vast majority of the audience, I would say about 2/3 of it, was within 6 dB of level front to back and left to right. And that's a great starting point. And there are other ways to make that better. But if we have 2 speakers on sticks on the ground and it's the right speaker for this size audience, we're going to be in great shape. And this applies to big sound systems. This was a show I was on in an arena, and you can see this is a whole lot of arrays in the air. It feels really intimidating if you walk into a big size show, but it's the same thing. We're making sure the right speakers are in the right place, pointing in the right direction, and covering the floor. So this is an arena floor. It's a basketball court. So you need to make sure everyone there seated could hear, as well as everyone in the bowl. So I'm just multiplying this effect, having multiple speakers in the air, just like a lighting designer has to light the entire thing if their job was to light the bowl and make sure that everyone can be seen. I'm putting speakers everywhere so that everyone could be heard. So at the end of the day, what we're doing is we're having speaker to audience matchmaking. So we need to make sure we have a good match so that everyone can have adequate coverage. So what are the benefits here? We need to have even SPL and tonal balance. That means you're not guessing. If you have a digital console and you're using an iPad to walk around and mix, that means you're not having to go check the front row and the back row, the side, the left. You can trust that's going to sound tonally balanced and even everywhere. You can also predict in advance what gear you need. I promise we'll get into the calculations and specifics and how to make all this happen by just setting the stage for why it makes sense to fit a speaker to an audience shape. And it's also less wasted energy. If you find the perfect speaker to cover a perfect amount of your audience, you're not spraying all over the walls, you're not making it less intelligible. It really makes for a clearer, more intelligible experience. And this is really important on corporate shows when being able to hear every single consonant and vowel for that matter, is really important. Okay, so here's a show scenario. I'm going to bring us back to our two speakers on sticks right here. These are QSC K12s on top of their subs. We're not going to worry about subwoofers today, but this is a speaker that I think a lot of people have used, and it's self-powered. It's about $1,000. It's a workhorse. I really enjoy the speaker. I've done 100 shows with this guy. And here is our show here. We've got a stage that's 12 foot deep by 16 feet wide, just to set kind of our dimensions here. Our audience starts 10 feet away from the stage, and then our audience is 50 feet deep by 64 feet wide. So that's an easy measurement. You could take one of those 100-foot roll-up tape measures and easily measure that about where you think people are going to be standing or just where the chairs are in your audience. That's a really easy measurement to get in the field. Okay, so the right speakers, step one in this analysis is already decided for us. We got K12s in the truck. That's what we're stuck with. So now we need to figure out what's the right place and then the right aim and coverage. So those questions are, where should we put our speakers? And then are they enough to cover our audience? Remember, we're lighting designers. We want to make sure the entire stage is lit evenly. We want to make sure our entire audience is covered evenly. So there are two big mistakes I see over and over again in the field. When I address those, then we'll move on to the specific calculations you can use to make sure you got the right speaker for your show. So using the stage as your guide, not your audience. So I went into Google and all I did was put small outdoor concert and just looked what the first page brought me. And I just clicked on the images tab and this is what I saw. A stage with the speaker stack directly left and right, facing straight forward. And again, a small outdoor stage with the speaker stack right next to the stage pointed straight forward. And again, a stage, speakers right next to the stage pointed straight forward. So you get my point here is that this feels like the default position for many people to do it. So if I were just doing a Google search and what does everyone else do with a pair of sticks and a couple of speakers on top, I would do that. I would argue that this may be a helpful place to start as like an anchor, but is definitely not the end all be all. Because why? It only sounds good in front of the stage because those lights, those speakers are only pointing what they're directing right in front of the stage. So what about everywhere else? How can we make sure that no matter where you're at in the audience, and sometimes we can't control how big they are, is covered and covered well? And number two, the biggest mistake is you're ultimately guessing on coverage. It wasn't until maybe 4 or 5 years ago that I really started to dive in and figure out, I had memorizing what the coverage angles of the speakers that I usually worked with. And we'll talk about how coverage angles was really important in just a minute, but we're ultimately guessing. So back to our original show scenario, I have here in these yellow boxes, those two speakers that whoever this audio person was in the show used, but this one's pointed here towards the middle. I mean, what about these people on the side? Is this speaker wide enough to get out? Is its lens wide? And this one pointed over here. Is there anyone standing beyond it? So we ultimately, if we don't get this right, it's wasted energy. It's unintelligible outside of the coverage, and the back row and the sides sound terrible, which none of us want on our shows, or you don't get hired again. I want us to have a mindset shift here and start thinking about even coverage that is predictable And we can borrow even from lighting designers that they know the lenses that are inside their stage lights, and these are particularly called LECOs, and we can see how it progressively gets tighter, a little bit wider, a little bit wider, and a little bit wider. We need to make sure that it's all covered. So that angle for us is the nominal coverage angle in a speaker. It is the number one spec I look for on any speaker. Forget power amps, forget input sensitivity. That can all be figured out or to a certain degree, especially if it's a built-in power amp, it's already a match made in heaven. And so if I have external, I want to make sure I'm not blowing anything up, but it's the number one spec I look for on a speaker when I'm putting it in a system. So on a K12, this is the spec sheet, and I looked at nominal coverage angle and it has 75-degree axisymmetric. And axisymmetric is a fancy word of saying that both the horizontal and vertical coverage are the same. So it's like a cone. So it's a 75-degree cone. And those red arrows drawn there are at a 75-degree angle. So we can know that the high frequencies in that speaker are able to be steered in a 75-degree angle. So at the very top, when I showed you those speakers that were real tight, there was like a 10-degree speaker. Those were really, really focused and tiny. And so this is 75. So it's a nice middle of the road speaker. Most of the speakers that are two-way and just throw up on a stick and make a show go, those are usually anywhere between 60 and 90 degrees, depending on your manufacturer, depending on what you get. So I like this 75-degree number because it can be used as a floor wedge, as a main PA, and gets a lot of work done. So in the prediction software, I like to use Map 3D. It's all Meyer sound products. There's no QSC, but this is an 80-degree speaker, and that's really, really, really close to 75 degrees, in my opinion. And this is our weather map. If we have one speaker in the center, that's about how it would cover that size audience. Another speaker I work with a whole lot is the RCF HDL6A. It's a line array speaker, completely different functionality and purpose. Its horizontal coverage angle is 100 degrees, so it's pretty daggum wide. You're not going to see a whole lot more than 110 or 120 unless you get in those weird Bose systems, but that's a 100-degree wide speaker. But its vertical coverage is a tenth of that. It's only 10 degrees vertically, so you can have variable coverage change in the same speaker versus horizontal versus vertical. So I couldn't find a picture from it top down, but that's close enough for 100 degrees horizontal versus and that's what a 100-degree speaker would look like on that same map. You can see the 80 degrees is a little bit tighter, and this is spreading out, it's orbing around a little bit more on my audience versus a 10-degree vertical coverage. So these are meant to be stacked up in a big long line, and you can vary up the coverage angles between them. So that's its maximum splay is 10 degrees, or it can be used on its own as a front fill. If it's on the edge of my stage, I need to make sure that I have it aimed right at people's heads because 10 degrees is not a whole lot of wiggle room, right? So this is, again, a 10-degree speaker, really tight. See a huge difference between 100 degrees right here and then 10 degrees. But how can we actually use this data without any fancy software? I don't want to download any prediction software. I don't have to plan my show. Everything is run and gun. I can't always have it nice and neat. So I have three letters for you, FAR, forward aspect ratio. So I stole this from Bob McCarthy's book. Got it right here. It's like 500 something pages. And so if you're like super nerdy like me, you'll read it. But if you don't, here's just a really brilliant nugget from this book. It's basically using trigonometry to make this all happen. So it basically answers the question. I have an X size audience, and it was about 60 feet by 45 earlier. What speaker perfectly matches this shape? Remember, a 10-degree shape was real narrow, or 100 degrees real wide. What speaker is a match made in heaven for this audience size? So this is an 80-degree speaker filling up the yellow rectangle of this audience size. And this is a 20 speaker failing at doing that. So the 80-degree speaker was the match made in heaven. The 20-degree is not. So we need to start with the audience, which goes against that mistake they see everyone making. They usually place their speakers based off the stage. They forget about the audience and just say, okay, I'll put left and right next to the stage. Let's blow and go, have a great show. So we need to start with the audience in mind first, because they're ultimately hearing the show. They are our target. Okay, so how do you calculate audience FAR? If you got past fourth grade math, you can do this. It is depth divided by width. All right, so back to our original example, the audience is 50 feet deep by 64 feet wide. So let's throw that in our calculator. 50 divided by 64 is 0.78. So what I want to introduce here is a section from my Audio Math Survival spreadsheet. Kyle's going to have the link below for us where you can go snag that, but it does that for you, and it creates an audience FAR 0.78. Right below that, it should spit out the coverage angle of the best speaker in the world that would fit there. But instead of giving me an angle right now, it says subdivide and conquer, because it's actually not possible for a single speaker to be able to get wide enough to fit perfectly to an audience that is wider than it is deep. So it says, hey, subdivide and conquer, but a single speaker can't do this show. But the good thing is we got two. We have two speakers, a left and a right. So what if we just magically assigned the left speaker to go over to the left half of the room and the right speaker over the right half? And all of you stereo geeks are probably like trying to shoot me right now, but in live sound, that's not a big of a deal. You think we could have that fight later, but all I did is I did the same calculation, depth divided by width, but instead of my width being my whole audience, I just cut that number in half, because all I care about is this zone, the house left zone. I need a 50 divided by 32. It gives me an FAR of 1.56. And that uses a fancy calculation we'll talk about in a minute that says, hey, you need an 80-degree speaker to perfectly fit on this show. So let's figure out, okay, I know what speaker we have now. Let's make sure they are in the right place. So I've got these two 80-degree speakers. I've placed them about downstage edge equivalent with the front of the stage, and I've aimed them right, or I've placed them in the middle of their zones. I'll say it's a really easy question, like where do I put a speaker? We can talk about height and trim height, and that definitely plays into our Z-axis. But if I'm placing a speaker, I want it to be in front of the stage so I don't get feedback, but I want it to be where it is at the middle of its own zone. I don't want to have to like go from way off to the side to point over. I'm trying to get in the middle of that zone. As you can see here, both of those speakers are set up for success. They're pointed straight in the middle of their zones. And that goes right into aim. So I need to make sure that I aim the right spot after I've already figured out the coverage is going to work. An easy way to figure out your aim, even if you can't get your speakers perfectly set up in the middle, is shoot through the middle of the middle. This is something you'll hear come up again and again with how I teach sound system design, is put the speaker in front of the stage, probably get it as high as you can, then aim it through the middle of that speaker's zones. And again, I just drew blue lines right there, making these crosshairs. So the speaker is set up in the middle of its zone, and it's pointed through the middle of its zone. And we can see here that we have subdivided and conquered, and they're now covering everything we need to make sure we have a great show in this space. Yeah, so winning. So again, if we had two 10-degree mains, this would do a terrible job of making the show happen versus our nice, even weather map we have here. So yeah, so that results in under coverage. No one likes that. People can't hear, and you get fired. So if we have two 100-degree mains, is that going to help us? Is wider necessarily better? I would say I'd rather have a wider speaker, a little bit too wide speaker than a little bit too narrow. You can have more energy that overlaps with speakers that can cause comb filtering. Some of it could be technically wasted if you're already struggling with SPL. You have more off the walls, but everything is a trade-off, right? And so if that's what's on the truck, I'd rather have something that's a little bit too wide than a little bit too narrow. So now let's go in reverse. Let's say we are like way back in the beginning. I have QSC K12s. They're a 75-degree speaker, and I can't change that. Is it going to work for the size audience that I can measure? So speakers and audience shapes both have an FAR. So that answers the questions. I've got 100-degree speakers. What audience dimensions work here? So we're going to use 100 degrees, not 75. Apologize. So the speaker FAR formula is 1 over sine of the speaker coverage in degrees divided by 2. So if that scares you a little bit, it's here in the spreadsheet. All I got to do is put in 100 degrees right there, and it'll spit out the FAR for you. All the orange cells are inputs, all the blue cells are outputs, and that's right under the previous calculation that we did. So that tells me if I have a 100-degree speaker, that speaker can cover an audience zone that has an FAR of 1.53. So this is a speaker, and I've drawn a perfectly sized rectangle to fit that, and it's doing a pretty good job of covering that, but maybe not so in the very back, but we can get that to a little bit later. That goes into our height. It's often good to get speakers up in the air so they have a better chance of making it not as big of a discrepancy from the front and the back. We've been focusing mainly today about horizontal coverage, so we'll get to that in a later video. So here are the key takeaways from today. Do not just simply put a left-right stack next to your stage and call it a day. You're going to have feedback issues. Who knows what the coverage is? If you're stuck with that, you can make it work, but place speakers in the middle of their zones and point them through them. I want you to start thinking like a lighting designer. How can I most evenly cover what's going on and have an audience first? A lighting designer, yes, they have a truck that shows up with their fixtures, but they have to make sure that everything is easy, or the camera department or the technical director is going to get mad and say all his shots look off. Once you think about matching speaker shapes to audience shapes and being able to be fluid with going between the FAR for both will help you do that. And please just subdivide and conquer. Stereo's nice when you got it, all for it in ears and in studio music, but in live sound, I would much rather, if I had to choose between an even tonal experience than this nice overlap stereo type of effect. Make sure to grab my Audio Math Survival spreadsheet. It is at the link below. Thank you so much, Kyle, for having me on, and I will catch you guys next time.